Okay, well, this class is getting through the work very fast. I'm releasing my responses. I don't say answers. I give you my responses. They may not be perfect, and then they don't claim to be the only way of responding to these any programming needs that I show you. Now, let's just have a look. Then. You're going so well that a lot of you won't even need to look at these. It's quite obvious they're up and running. But if you've not got it working, if it's not running in Visual Studio, then you can copy and paste some code off here, or you can look at a complete Visual Studio project, and you can use this to load into your laptop to make sure your laptop is working okay. That helps. Okay, now I'm going to have a look at Azure Functions, which is starting to get into next week's work. We're probably now we've got the basic MVC method working. You should find that quite straightforward. The sort of methods you're coding are the same as what you've done in other courses. In fact, some of them are copied from other courses. Did you notice? The book one is from Fundamentals of Software Development. Yes, all your old friends are crawling out of the woodwork, just trying it out, mostly exercising the framework and getting to know it. So we should have no problem with this, the remote methods. Now, getting into something that's newer and more distinctive to cloud computing, I want to look at JSON, which I may not have time to do today, but I'm going to try for it, and the Azure Functions, both of which are going to be in your test. Did I tell you, I think we've got a test in 2 weeks from now. We move fast on these 8-week cycles, but a lot of what you're already doing test practice questions with a lot of these exercises. Okay, so with that, let's have a look at our activities, and we've got the starter kit. You've been doing the controllers. Some of you have experimented with making new controllers, for example, and giving them different names, and then seeing how that changes the address. It works just fine. All good. There's an exercise here in making sure you've got your database working. This does nothing more than load some data into the database. I'll just leave that to you. Let me know if it doesn't work, and I'll check to see if there's anything wrong with your database membership. Okay, the function apps, this is where things get a bit more interesting. And I'm already been warned by some students that this document is getting a little bit out of date, especially on how you first start a function app. Let me have a look at this and see how it goes. We're going to use this as an editing portal. And we've got the very strange naming for this. You know, there's what I can only describe as nerd jokes that gets through into the names of some of these technologies. Like, this is called a serverless function. And what it means is it doesn't mean that you don't have a server. It means you have less server setup to worry about because a lot of it's been done for you. Another one that annoys me is NoSQL. Have you ever heard of NoSQL? It stands for Not Only SQL. These are databases that do SQL, but they do some other alternative storage layouts and query languages intended for use with very large quantities of data. Okay, well, we'll head for the Azure Functions, which are, of course, one of these, and I'm going to get into my pen drive. It's not there, so I'll go directly into here. Okay, now Azure keeps changing it, but I've mentioned the techie app and the techie joke, and that might be called a function app or a serverless function app. But let's start doing that. It's a lot closer to the raw data as it moves around the internet, which is why you get more code, and instead of automatically taking a number as a string and converting it into a double, you actually have to put in the code to do that. So where you got an automatic parsing, that is understanding of that string that goes A equals 4 and B equals 7, here you actually have to deal with it directly. And the query is the query string with those equal signs and ampersands sitting in there. So this is a lot raw, or much closer to the reality than this, which does a process called parsing, or making sense of data in string form, and it does it for you. All right, so this is very educational because you have to go right in and deal with it in its raw state. It's a lot more real. Okay, let's try it out. And we're there's even more to it than that, because we've got to get A and B out of the raw internet data. We've got quite a lot going on. Now, so let me try that out. I'll need to get into Azure, and I'll do this in my own resource group. No, should I, or should I share it with my student friends? No, I won't. I'm not feeling very sharing at the moment. I'll go and put in my regular resource group, which at the moment is East 02. And I'm going to make a new function. I'll get started. Function app. Enter a name for your app. Okay. I'll call it, this is actually a group of functions, so I'll call it function test not available. Obviously other people have thought of this. Function test, I must be up to about 5 now. I think I'm probably better with a small f like that. So function test 5, there's my subscription, my resource group. I'm going to use an existing one, which is East 2. I like to use Windows. Hosting plan. Oh, I don't know what that is. I have no idea what this is. I've not seen this before. Oh, pay per execution. All right, consumption plan is a much better idea. But what this does is this will use up your credits by paying in advance. It's like, it's like prepay or a hop card. And this is like paying just whenever you use it. Now, a test one that a student uses is much better to pay as you go or use a consumption plan, because you're not going to use it very much. You're only going to do a few tests. It's not like a real life one of these, which would have hundreds of people using it for a special calculation that lots of people in an industry need, which is normally what it's for. So consumption plan is good for us. Don't forget to change the location to Australia East. If you don't do that, it'll still work, but it'll go slower. And storage, create new, use existing. I think it's usually best to, I don't have any, do I have any existing on these? I could share with function test 3. I don't think it matters very much. It doesn't seem to make any difference to using up the credit dollars. But I'll share with function 3. Application insights. might use up credits. This is where you get lots of reports on who's using it and who's visiting it. But you know who's using it because it's only you, so I don't think you need the application insights. So I'll create that. And so it takes a little while to set it up. What's this intended for? Imagine there's a whole industry with several companies, but when they're doing their programming, there's some calculation they all have to do that's based on their industry. I've tried to give an example of that with the House on the Hill, which may be a real estate industry association would provide that, and lots of real estate companies would use it. Therefore, you wouldn't put the calculation inside your own programming because it's an industry standard. You have to call on it from the industry standards website, and they maintain it so everybody's using the same function. But the function itself is quite a little piece of work, and therefore one of these lightweight cloud functions will do the job just fine. So special calculators that are used by more than one company in an industry, that's what this is for. And has it done it yet? Deployment succeeded. So notice what happens. There's a time delay while, for example, the Azure creates a folder on a server to put this. And so I get my notification here, and I go to the resource, and here's my function app. Now, function test 5 is like a container. It's a bit like the controller in our other MVC example. And in here, I can make functions. So I have to click the plus sign to make the actual functions, which is another name for method. Okay, it's got some questions for me. What's the development environment? Well, what I want is in Portal. Because this is a way where you don't need Visual Studio. You get a mini Visual Studio in the web page where you do your coding. And for a mini program, which is what this is, I think this is a really good idea. I've found that Visual Studio actually seems to make it more complicated, and you have to install something extra in Visual Studio, an Azure workload. Oh, I'll just do the whole thing on Azure and continue. You may now more templates. I want the HTTP request. So it's like a little mini web page that just produces a number, or later on it's going to make us some JSON code. So I click more templates, and I wait for more templates. A bit slow today, Azure. Have I clicked in the right place, I wonder? Maybe the link's not where I thought it was. Finish and view templates, all right. Oh, okay, I had to click the finish button when I'm not finished at all. I'm only about halfway through. Okay, this is the one I like, HTTP trigger. So that's basically a mini web page for machines. Name, here's where we give it a meaningful name that we actually does something. I'm going to add two numbers together. I can do something better. Quick, what would you like? Since you're so good at calculators, how about the volume of a sphere? Know this one? Yes. Vol. Can I spell vol sphere? So I've not got something different. It's a function. Let's create it. I should probably have actually called it get. Usually these are named get when you're doing a calculation. It's often done. But okay, it starts off by giving me some example code, and And a lot of it I don't like because somebody's showing off how whoever did this at Microsoft was showing off how many advanced methods they know, and I find it a bit confusing. So I like to simplify it a bit. Now, to begin with, what we've got here is get or post. I have to ask myself. Get is simpler. That's what you've been doing, where there's just one line where there's the address, and then there's the question mark, and then there's the data. Okay? It's considered insecure, but only because when people type it, spies can come along and see the name of the function by looking at the address at the top of the screen. There are stories, this has actually been tried. People come along as visitors, as guests, to visit a company saying they want to buy the company's services and be customers, but they're lying. They're not customers at all because they've got hidden cameras, and as they walk through the open plan office on the way to their meeting with the boss, they've got the little video camera videoing as they walk past the workers' screens, and they're looking for any information there that they can use. And a get that's been tested might give a hacker information like the address of a function and what the input parameters are. You see what I mean? Add, question mark, A equals 4 and B equals 7. The hacker knows there's a public function called add, knows that it's an account controller, and knows that the input parameters are called A and B. So that's what's wrong with get. However, get's advantage is it's very quick and easy to run and test. But it's not that bad, because mostly when you're doing this, the get would not be run by a human operator typing it. It would be done in code, often in JavaScript, and so that's actually hidden. So the get security is not that bad in real life. The main thing you have to note is that get is limited in how much data you can throw on the end of an address. You shouldn't put more than 1,000 characters, and even that would be over the top. Get is for very small, simple functions. So in most of the work we're studying, get is quite okay. But post is considered more secure and better. It has two advantages. It's not going to show up on people's screens and be seen by spies. And it also is capable of, I think, up to 10 megabytes instead of a maximum of 4 kilobytes. And depending on the browser, it may be as little as 1 kilobyte for a get, but 10 megabytes for a post. So I hope you get the idea that post is better and is considered more professional. So let's study both of them. The person who's given the example code here has actually done both in the same piece of code. It's not intended that you run this because it's, and the person has also done a quick way of writing an if statement that's kind of a bit much. So I'm going to simplify it down, and I'll just do a get. Over here we've got test. There's a test panel, and I slide across to see it. We can test with post or with get. Post is often quite difficult to test with because you can't just type it into an address. So it's quite, it's good that the function lets you do a post. Notice the post is JSON. Actually, I will do it as post because then I can introduce JSON, and that's always good. All right, now we're going to do the volume of the volume of a sphere, and I'm going to do it with post. So the first thing I need to do is get rid of all the get. Then this is optional, log information. I'm going to get rid of async. Async is good. It allows a server to more efficiently handle a lot of requests at once and not sort of jam up because of it. But hey, I'm still going to get rid of it because I'm trying to not teach too many elements at a time. So I'm going to go do a simple synchronized function, which is what you've been studying in other courses and what you're used to. There's the HTTP request, and I don't think through a post we actually need this, do we? Request body, oh no, we do. Okay, this is everything, including address, headers, codes, and data are in a request. So the REQ object is everything that comes through on the internet, and that's why there's a lot of code here which has got to sort it out. Now, string request body equals, I'll get rid of await because that's part of the async style of and read to end async. I'm just going to read to end. So a stream reader is sorting in data that's arriving in your computer from another computer. It's known as a stream, and a stream reader object takes often data that's arriving in small chunks and glues it. It's like a jigsaw puzzle that's got to put back together to see the whole picture. Packets travel across the internet in quite small pieces, so that you may have a stream. If you imagine them as like drops of water, you've got this water pouring into your computer when somebody moves a big amount of data like a video, and you've got to put all the droplets together in a bucket to get your water, so you've got what's come into your computer. That's a bit of a metaphor there. I did get metaphor of the day. So that's what a stream reader class does. It makes sense of data that is arriving in lots of small packets and needs to be joined back together again. Now, here's something that's quite unique to the C# programming language. Usually, you would have to know in advance the data. In the C language, you normally have to write a class that describes your data. If your data has got more than one number especially in it, or a mixture of information like numbers and descriptions and labels, you'd have to lay all those out and say string variable name is a string variable name, double variable name, int variable name. You have to describe your data very precisely. However, this is a casual function that more recently in the C# programming language, Microsoft has allowed us to go slacker, a bit like JavaScript, and write code that will handle unpredictable data. So what we can do is dynamic data is an object where we don't know in advance what's in it. And we don't have to. It will automatically, at the cost of some speed and efficiency, but it will automatically sort itself out from the data coming in. Okay, we then have dynamic data. Now, at this point, I'm going to just say double R. By the way, it helps to know that the formula for a sphere is 4 divided by 3 times pi times the radius cubed. Double R equals data.R. So we're looking for a variable called R that's going to be a child of the data. Then I'm going to say double V equals 4 divided by 3, I'll keep that, times pi, does this has math dot pi? No idea. I'm not sure if the math class is available in this kind of function. I'll know soon enough when I try it. If it's not there, I can get it by putting a using statement up the top. Math's pretty basic to most languages. I'd be very surprised if I had to ask for it as an optional extra. Well, for a simple example, there's a lot of value here. Now, I could say r to the power of 3, and I could do it the really classy way using the power of 3, but there's an easier way. If you're in a hurry, how do you do r to the power of 3? And I'll ask student number 2 here. Hi, how would I do r to the power of 3? What? Sorry? Radius. Maybe I should call it radius. It's just the radius, and to get a volume I have to go r to the power of 3. I could do this. Math.pow, I'm not sure if it's upper or lower case. I'll assume it goes like that. Sounds like something out of Batman. And then it would be r, 3. So I could do this, but I have struggled to remember the formula, and I'm not sure if that's the case. There's a way simpler way of doing that. Any ideas? Area of a circle. Do you remember how we did that? No? Okay, I'll ask someone else. Student number 3? Did you do area of a circle in the exercises? Pi squared? No. Pi r squared. That's right. How did you do the r squared? Can you remember? Well, quickly look it up. Everybody now is scrambling to look at the notes, and because I'll ask you next. Student number 4. R times r squared. So how would you do r cubed? Yes. You could struggle with remembering your classes, or you can just remember what it actually is and go r times r times r, which is a lot simpler and doesn't need any special classes, objects, or static classes, or I think that's what it is. Math is a static class. Okay.
Does it accept R with the up arrow 3?
Not in C#. Unfortunately, it's math.pow. Yeah. It's very much into object parent dot child and following the methods with parentheses and input parameters. So I'll now return. Now I think all this OK object result is just for the purpose of sending out strings. I'll try saying return v and see if that works. Now notice I'm not getting what I get in Visual Studio, which is the help with like it's not telling me if I'm right or wrong, but it will when I try to run it. So although the debugging is not as good, it does have debugging in there. I'm going to comment this out. I'm not going to throw it away yet because I don't know if I need this method here. I don't think I do, but I'm going to just make sure of that. I'm going to do something else. I don't actually need a formatted HTML result. I just want a number, so I'm going to simplify it down to string. Okay, let's try this, save and run. I didn't set the R right. Yes, so it's not going to be very happy at all, and nothing much happened. here's my result. Do I even have a result? Doesn't look like it. View files, no. Test, no. It doesn't seem to be doing anything actually. I'll go and set this up properly. That might be a very good idea. And what I have to do here is say R. Why isn't it responding? Later, a few minutes later, we ended that exercise in class with a mysterious blockage. I was unable to edit this data here. So just after class, I've had an idea. Bing! And I've tried changing from Microsoft Edge to Google Chrome. So this looks the same, but I've actually closed Azure and opened it again in Google Chrome. Let's see what happens. It works. So we want an R, and let's have a sphere with a radius of 5. That should be suitably interesting. And we'll save it, and we'll run it. And what happens? We scroll down to see the result, and there's a result. Now, this display here, logs and console, show us what happened. So what we've got here is information, and if there is a programming problem or a logic problem, then that's going to also show up. So for example, if I make an error here, a mismatch, let's have, this would be an easy error to make, that I call my parameter radius on the input data, but I call it R in the code. So I've now got a mismatch between radius and R. Let's have a look what happens. It's thinking about it and thinking about it. Maybe it's stuck and I should start looking for a result coming through. Oh, here it is. Status 500 internal server error. But over here, we do get some useful information. And I think that information executing. Anyway, in red, failed cannot convert null to double because it is a non-nullable data type. In other words, it's complaining about a null. And what is the null? This is it here. Here is a parent data. It's looking for a child R. That child does not exist. Therefore, this is null, and here's where it throws the error. Does it tell us what line the error is on? Error, failed ID. It would be really nice if it said it was on line 14. So I'm a bit sad about that. However, I'm able, with that keyword null, convert null to double, I can see straight away what's going wrong and where it's happening. And let's correct it. And we can just make it a bit bigger. 10, what would that be? 10 times 10 times 10 is 1,000. It would probably be more like 4,000 with the way pi operates. That's just a quick estimate of 4,000. Save it, run it. That's actually not correct. No, it's like 4/3 hasn't done anything. me have a look, because that looks like pi times r cubed. Yeah. Pi is working, so we know that is correct. 10, that's 10 times 10 times 10 times pi, and that doesn't. It's almost, it's done itself as an integer. You tricky computer language. Okay, I'll try that again. Save. Run. Let's have a look. That's much better. Okay, so be careful with data types. Even a simple exercise like that can teach us a lot, and that was really interesting. And it pays to get out the calculator and check something like that, because there are often surprises lurking in there. 4 is an integer, 4.0 is double, or any other related type like single,